Alright, so we are looking at the models of allosteric cooperativity. Now, we've seen the two types of allosteric cooperativity as what and what? Positive and what? And negative, right? Now, the models of allosteric cooperativity, we still have two types, two models of allosteric cooperativity. Now, the two models of allosteric cooperativity, the first one here is the concerted model. Now, if you don't want to call it the concerted model, you also call it MWC model. Please, this is a typical exam question. Just like I told you, if it's not come out, I will not take it now. If you don't call it concerted model, you call it MWC model. And this MWC is a contraction of the three persons' name that brought about this model. M here is Monod-Wyman-Changeaux. So it is also called Monod-Wyman-Changeaux model. So it's either you call it concerted model, MWC model, or what? Symmetrical model. Now, if you are asked to write on this model and you don't know any other thing to write, tell them, start somewhere. Tell them the concerted model is also called what? MWC model, or the what? Symmetrical model. You don't write something. Now, this model proposed that proteins exist in two states. Enzymes exist in two states. Now, he said this model proposed that proteins have two conformations, two states. Which state and which state? Tense state. Tense state represented as T, and the relaxed state represented as arrow. Now, what do you think? If the enzyme, now let's look at this enzyme now. If there is no ligand, like there is nothing bound to the enzyme, will it exist in the tense state or the relaxed state? If there is no substrate attached to this enzyme, will it exist in the tense state or relaxed state? Okay, in nature you say that it's relaxing, have you? But the opposite is the case here. When there is no ligand bound to the protein, it exists as what? Tense state, right? But if a ligand is attached to the protein, it exists in the what? It exists in the what? Relaxed state. Now, this model states that proteins exist in two states. What and what? Tense state and the what? Relaxed state. That when there is no ligand, the protein is predominantly in what state? In the what? Tense state, right? But if a ligand binds to this protein, it will change the conformation to what? The relaxed state. Now I'll use this to explain this. So listen up. Now, this is the protein, and this protein has 4 binding sites. Listen up. This protein has how many binding sites? So do you call it a monomeric, dimeric, trimeric, or tetrameric protein? Tetrameric, right? Because it has how many binding sites? 4 binding sites. Now, box is used to represent tense states, and cycle is used to represent relaxed states. Now, if you look at this enzyme here, this protein here, is it in the tense state or relaxed state? Tense state, right? Why? Because no ligand is bound yet, right? But if a ligand binds, it will change to what? The relaxed state. Now, one thing you must note about the concerted model, why it is called symmetric model or concerted model, meaning here we have tetrameric protein, right? 4 units, right? Did you see me write something like this? Only one unit changing to the relaxed state. I think all of them, they are changing at once. Please take note, because this is what differentiates this model from the next model we are going to take. The next model, all of them, they are changing one after the other. But in the concerted model or the symmetric model, you see it is an all or nothing effect. It's either all of them are changing to the relaxed state or no one will change. Do we get that? Now, concerted model, what you can easily use to remember concerted model is all or nothing. The drawing is easy to draw. I will explain and you know how to draw it without cramming. But just know that box is used to represent what? Tense state, right? And arrow is used to represent what? Relaxed state. And in the constructed model or the symmetric model, when they say something is symmetrical, in biology you are taught that human beings are bilaterally symmetrical, right? Meaning if you divide here like this, what is here is the same thing as what is here. Is it not? Good. So when they say something is symmetrical, meaning all of them are what? The same. The change of state from the tense state to the relaxed state is an all or nothing effect. Meaning it's either all of them are changing to the relaxed state or no one will change. Do you understand that? Now if you look at this, as ligand binds, all of them change to the relaxed state. But the arrow is reversible, meaning at any time, if you remove the ligand, it's to still go back, right? To still go back to the tense state. Now, if you are drawing this diagram, very simple. All you have to do, constructed model, your mind will just tell you that all of them are changing at once, right? Yeah. And you know that box represents tense and circle represents relax. So you just come here now and do like this. And this one is tense state, right? You now do relaxed state, Abi? And we say all of them are changing, is it not? Diagram on the board, please listen up. All you have to do is to write. This is a tetrameric protein, right? And this is in the tense state. Then interconvert all of them at the same time to the relaxed state, right? Yes. Once you do this, brothers and sisters, you are almost done. Yes. All you have to do at this point is you'll be adding substrates one after the other. You put substrates in them one after the other. Now look at this. After this point, what we did was we added one substrate plus S, we add one substrate. Plus S again, we added another substrate. We now have two. You just be adding substrate until you fill up everything. You come here to you'll be adding substrate one after the other until you fill up everything. Then they can be interconverted at any point. Now, constructed model is also called the what? MWC model, right? Or the what? Symmetric model. And it states that the protein exists in how many conformations? 2 conformations, which are what? Tense state and the what? And we said the tense state, the enzyme is there a ligand bound? No, right? If a ligand binds, it changes to the what? Relaxed state. And we said that the change in conformation from the tense state to the relaxed state is what? An all or what? Nothing effect. All or nothing effect. If you ask to explain that, please draw this for them. And I've shown you a simple way of drawing it. Just draw these two. Then after that, start adding your substrate one after the other until it is filled up. So I just did one substrate here. Some of you that don't like stress, you will just come here and do something like this. Then you now put 2 lines under and move to the next question. Please, if you shorten it this way, they also shorten your mark. Ensure you do it this way, long. Alright, now we've seen the 2 models of allosteric cooperativity. And the 2 models are what and what? Constructed model, the first one we looked at, and what? Sequential model. If you don't call it constructed model, you also call it what? MWC model, right? Or what? Or symmetrical model. Now the second model of allosteric cooperativity is the sequential model. If you don't call it sequential model, you call it KNF model. And the KNF represents the name of the persons that brought about this model. Koshland-Nemethyl and what? Filmer. Now, when they say something is sequential, what does it mean? One after the other, right? They say do it sequentially now. It means do it one after the other. Do it symmetrically, meaning do it at the same time now. Is it not? Now, in the symmetrical model, it still proposed that proteins exist in 2 conformations, tense state and what? Relaxed state. But here we have series of intermediates. Now, the change in conformation in the sequential model is done one after the other. Now, if you look at this, This box here, the box represents, is it 10 state or relaxed state? 10 state, right? When a substrate comes or a ligand binds, you see that only one of the protein, only one unit, subunit is changed, right, to the relaxed state. The other ones remains the same. If it was in a concerted model, once a ligand binds, all of them will change at once, right? But now, one changes. Then as one changes, it will now cause a conformational change in the one at the adjacent. So as another ligand binds, substrate binds, the second subunit will change. So you just be changing the subunits until you change all of them to the relaxed state. So you see now that in the sequential model, the change in conformation from the 10 state to the relaxed state is done one after the other, right? Now this A and B should not confuse you. We are just using A to represent one of the states and B to represent the other state. Here I'm using A to represent the 10 states, while B for the relaxed state. But you know, substrate is binding, so that's why I said BS. Other ones are still in the other states. So the major thing you have to note, please, in the note I've given you, you must not cram it. You must not give them in exam exactly how I've given you. Understand, fix it in your terms. If you're asked to write on the two models of allosteric interaction or allosteric cooperativity, all you have to do, number one is what? Number one is what? Concerted model, right? So you now write number one, concerted model, then put it in writing. Concerted model is also known as the what? MWC model, in brackets, Monod-Wyman-Changeaux, or the what? Symmetrical model. You now tell them that this model proposed that the protein exists in how many conformations? Two conformations, either the what or the what? Tense or the what? Relax. Then you now go on to tell them that when the protein, when there is no ligand bound to the protein exists in what state? 10 state, right? Now the change in conformation from the 10 state to the relaxed state is what? All or what? Not in effect. You now put full stop and you say this can be represented with the diagram below. You draw that diagram. Only that diagram have mark. If you like, explain without diagram. Now in biochemistry, the easiest way to get mark from your lecturer, to bribe mark, is to draw. I'm very serious about that, to draw. If you've been answering your biochemistry exam from year 1 to now to this level and you've not been drawing, that's the mistake you've been making. Draw for them. I'm not saying if they say define, you draw. Now the sequential model, also tell them that the sequential model is also called what? KNF model. And sequential, it states that the protein exists in two conformations, right? Tense and what? Relax. But here we have intermediate series of intermediate conformations. Now, the change of state from the tense to the relax is done what? One after the other. Put it the way you understand, Dan. It's done one after the other. It is not all at once. You draw this for them. So you can see, one subunit is changing. 2, 3, until all of them changes to the relaxed state. So those are the two models of allosteric cooperativity. Any question?